All right, so for Chapter 2, Section 3, we are going to continue to talk about solving LP problems, or the general linear programming problem. And we're going to focus actually on a subset of that called the standard minimization or maximization problem in this section. So the graphical method that we used in 6.2 works well when we only have two variables, because we can draw a 2D picture. We need one axis for each variable. If our problem has 3 or more variables, we would need to draw a graph in 3 or more dimensions. And that is difficult, if not impossible, to do. So we're going to come up with another method for resolving linear programming problems. So a general linear programming problem in n unknowns, so x1, x2, all the way through xn, is given by, we have our objective function p, which is a1x1 plus a2x2 all the way out to a and xn, where the ai's are real numbers, subject to some constraints where we have constants times our variables, and they are either greater than or equal to or less than or equal to something. The standard maximization problem is a special case of this that we're going to focus on in this section. So our objective function stays the same, but we are going to require that all of our variables be positive. So similar to what happened in the previous example, you can't have negative sunglasses or negative hats. So we're going to require all of our variables to be positive, and our constraint inequality is always going to be a less than or equal to. So it can't be an equal to, and it can't be a greater than or equal to. So we're going to study this subset in this section. So the method that we are going to talk about is a matrix method called the Simplex Method. All right, in this example, we are going to use the Simplex method to maximize the following problem. So we want to maximize p equals 3x plus 2y plus z, subject to the constraints 2x plus 2y plus z is less than or equal to 10, and x plus 2y plus 3z is less than or equal to 15. So we're going to use our slack variables to convert 2x plus 2y plus z into an equation by adding s, and x plus 2y plus 3z plus t is equal to 15, and then move the 3x, the 2y, and the z to the other side, leaving our p with a coefficient of positive 1, and then write our first tableau using that. So we have 2, 2, 1, s, 1s, 0, 0, 0, 10, and so forth. So let's go ahead and get our tableau entered into Excel. So our active variables are going to be our slack variables, s and t. And we're going to have 2, 1, negative 3. Our y column is 2, 2, and negative 2. Our z is 1, 3, and negative 1. S, 1, 0, 0. T is 0, 1, 0. And P is 0, 0, and 1. And finally, we have 10, 15, and a value of 0 for P. All right, so now we need to find our pivot column. So we look in our P row, and we find the most negative, so the largest negative value, which is negative 3. So this is going to be our pivot for our column, is the x. And then we calculate our ratios. So we're going to take our x value and divide it into the constants that we have over here. So that's going to be equal to, we're going to go h2 divided by b2. And we hit enter, and then we can just copy this down to the next one. You can type it again as well. And we get our test ratio is 5 and 15, and then we picked the smallest of the two. So this is going to be our pivot row. So then that means our pivot element is going to be the 2. So then we have our departing variable is going to be the one from this row. So s is departing, and the incoming variable is going to be the variable from our pivot column, which is x. So then when we start our second tableau, we're going to have x is our new variable, s departed, x came in, t and p. Our first row, which is our pivot row, isn't going to change. So we highlight the whole area, equals, and then we're just going to copy that row, which is b2 through h2. And remember, when we're doing row operations, we have to hold down Shift and Control, press Enter, and that will do our first row. Now we need to eliminate the 1 from our t column. So we're going to highlight our entire row, equals, and we're going to go 2 times our row 2, so that's going to be b3 through h3, and then we are going to subtract from it row 1, so that's going to be b2 through h2. Shift Control and press Enter. And we always have to check, make sure we did it in the right order, because our constant over here always has to remain positive. So there's more than one way to eliminate that. If we ever end up with a negative number here, we have to go back up and switch the signs. So if this 20 were negative, I'd have to go up here and make this negative and this positive. I'll purposely do an example of that here on the next row. So now we need to eliminate the 3 right here in this row. So the least common multiple between 3 and 2 is going to be 6. So let's go with equals negative 2 times, and let's do row 3. So that's going to be b4 through h4. And then I am going to subtract from it 3 times row 1, which is going to be b2 through h2. So notice this time when I press Shift, Control, and Enter, I end up with a negative number over here. So I immediately realize that I did the wrong elimination. So I select that entire row, and I'm going to go up here and copy this so I don't have to retype it. And let's go and, oops, I have to cancel, so let's try that again. I select this entire region, press Delete, and I'm going to come back up here and paste back in what I just copied. And so we had the wrong sign when we did this, so that means I need to change the sign on each of these. So that's negative, it becomes positive. Change that negative to a positive, hold down Control, Shift, and Enter. And this time we get the right value, which is positive 30. So now we have our second tableau. And if we still had negative values in the P row here, we would have to go through, find our pivot, and just repeat essentially what we did in the first tableau. But since there are no negative values in the P row, that means we're done. So now we take our active variables and we are going to find out what they're equal to. So our active variables are x, t, and p. So our x is going to be equal to h7 divided by the x value, which is b7. So our x is 5. Our t is going to be equal to h8 divided by the t column, which is f8. And then our p is going to be h9 divided by g9. We get these values, and then we have our inactive. And our inactive variables are all the ones that aren't active, so it's going to be y, z, and s. And those all have value of 0. The inactive variables are always 0. So then that tells us that our maximum value occurs at the point 5, 0, 0, and the maximum value is our p-value is 15. So just to summarize, if we would have had negative values still in the bottom row like we did here, we just go back and we keep doing this pivot until we've eliminated all the negative values, and once we've done so, we have our maximum value.